Hello dear students, let's see this problem of indefinite integral 0 to pi over 4 e to the power sec x 1 plus tan x upon 1 minus sin x dx. So before coming to this question, let me just recall you one indefinite integral e to the power x into fx plus f dash x dx. This integration is e to the power x into fx plus c. So for solving this question, here it is e to the power sec x is there, but here e to the power x is there. So I will be trying to put sec x as t. So if I assume sec x as t, and if I differentiate with respect to x both side, we will be getting sec x into tan x dx is equal to dt. So here sec x tan x dx is not there, so we'll have to make it. So we can write 0 to pi by 4 e to the power sec x as it is, 1 plus tan x as it is, and in the denominator let me multiply and divide by cos x. So this is 1 minus sin x upon cos x into cos x dx. So this will become 0 to pi by 4 e to the power sec x 1 plus tan x as it is. This cos x will become sec x dx, and in the denominator if you separate this is 1 upon cos x, which is sec x, minus sin x upon cos x is tan x. And one more thing we know, 1 upon sec x minus tan x is sec x plus tan x. So we'll use this. So here 0 to pi by 4 e to the power sec x into 1 plus tan x into sec x plus tan x into sec x dx. So if I multiply this, it would be e to the power sec x sec x sec x tan x tan x plus tan square x into sec x dx. Integration limits are 0 to pi by 4. Now we can take tan x common from this bracket part. If I take tan x common, I would be getting, let me erase this. If I take tan x common, it would be e to 0 to pi by 4 e to the power sec x bracket sec x upon tan x plus sec x plus 1 plus tan x into sec x tan x dx. Now I will be assuming sec x as t. So I would be getting sec x tan x dx is equal to dt. So now the integration limits will become, see, if x is 0 then sec 0 will be 1, so t is 1. If x is pi over 4 then sec pi over 4 is under root 2, so t is under root 2. E to the power t, this will become t upon tan x can be written as under root sec square x minus 1, so which is t square minus 1 plus this is t, this is 1, this is again under root t square minus 1. Sec x tan x dx will be dt. Now our integration is converted into e to the power t and bracket dt. So inside the bracket I will have to search for ft and f dash t functions. So that you can see very easily, e to the power t. If I take this t and under root t square minus 1, so you can see the derivative of t is 1, which is this, and derivative of under root t square minus 1 is t upon under root t square minus 1. You can verify by differentiating this under root t square minus 1 dt. So now we can say this is function of t, and this is the function of t derivative, that is f dash t. So the integration of this can be written as e to the power t into ft. So this is t plus under root t square minus 1, and the limits are 1 to under root 2. So if I put under root 2 here, I would be getting e to the power under root 2. Inside the bracket it is root 2 plus 2 minus 1, so 1. So root 2 plus 1, so it is e to the power root 2 bracket root 2 plus 1, minus, if I put 1 here, so it would be e to the power 1, and here if I put 1, so t is 1 plus 0, so this is 1. So the answer should be e to the power under root 2 plus 1 minus e.